Hey everyone, my name's Corbin Dunn, and this video is a walkthrough tutorial on how to create a VCarve Inlay cutting board using Autodesk Fusion. I'll be using the VCarve Inlay plugin that I wrote. A link will be down below in the description on how to get it. And I've already got 2 videos on how to use the plugin, so what is new here? First of all, still watch that first video, which I'll link to below, because I talk about how to get the perfect VCarve Inlay fit, which is super important. And thanks to all of your support, I spent a huge amount of time improving the plugin to make it better for 2D inlays and doing things like cutting boards. I initially focused on 3D inlays, and it was kind of a side effect that worked pretty well with 2D inlays. And I heavily relied on 3D toolpaths like Pencil, which work but don't work great for 2D inlays. So I reworked the plugin to use the 2D engrave toolpath for all the V-carving and the 2D pocket for all the clearance toolpaths. And the advantage of this is the toolpaths are just a ton faster to generate, and the resulting toolpaths look a lot cleaner for 2D inlays. I also did a ton of work to make it really easy to rework the plug layout, which I'll talk about in this particular video. So start by downloading version 1.4 or higher from my website. The link will be below. The one that's on the Autodesk site lags a little bit behind because of their review process, so you have to get through my site. Hopefully I can do auto updating of it at some point. It just hasn't been a high priority. And this isn't some hypothetical virtual design. This is an actual multi-wood inlay cutting board that I made, and I'll probably talk about more about this in the next video where I actually go and make it. Now, one of the things that I'm not going to talk about is how to create a design that's appropriate for V-carving, and it has to be very specific to your V-bits. If you want to know more about that, maybe comment below and maybe I could do some video about that in the future. So let's go ahead and jump into Fusion. All right, so here's what we want to do. Let's go ahead and do File, New Design. And for organization, it's always good to create a new component. And I'm going to name it Board. And inside this, let's show the origin. Let's go to the XY plane, and I'm going to go ahead and create a new sketch. And I'm going to go to the top side, and I have to go to the top because I have look at automatically turned off. And let's make it the lower left be our origin, and let's just create a rectangle. I hit R for rectangle. Let's make it 12 by 19, and I'm going to hit enter. Might be nice to use parameters for something like this, but this is an easy, fast way. Unhide the origin, finish sketch, expand the sketches, and let's rename that to board shape. And now we can select this profile, hit E for extrude, and let's make the cutting board, let's say 1.6, let's say let's do 1.6 inches. And it's going to create a new body. All right, maybe hit F for fillets, and let's add some softer corners here. So I'm just going and selecting all the corners really carefully, and then do something that looks pleasing for your design. Okay, basic cutting board, that part's pretty easy. Now let's talk about designs. You probably did your design in something like Adobe Illustrator. And inside Illustrator, you can have an artboard to represent your whole size. If you're going to design it in Illustrator, make your artboard's width and height be the height and width of your cutting board. Make the origin for the artboard be the lower left. And that way, when you export this, it will all come into Fusion very nicely if you do the right things. And of course, one of the best ways to export it is as a DXF. So before I export it, also note that I have different layers, which is really nice because that way I could have different color woods for different parts of this design. So once you export it, you can do File Export, and I'm going to export it as a DXF and give it a name. Your scale needs to be inches, assuming you're working in inches, and it needs to match the document units. So I already exported it. Now back into Fusion. We want to create that design on top of here, and the typical way would be to create a sketch right here in the top, but if you import that design, it's going to be flipped, and that just happens to do with the way that Fusion does the Z normal for a sketch. So we're going to do it a little bit differently to make sure we don't have any issues with it being flipped. And I'm going to go ahead and activate the main component because I want to create a new group for all the inlays. So I'm going to create a new component called the inlays, and it's activated. Now let's go ahead and insert the DXF. The plane sketch I want to insert it to is going to be this top of the cutting board. You could also create a plane and move it up, but you don't want to create a sketch on the top and use it. The DXF will come in flipped. So I can go ahead and hit the folder icon, select from my computer, find the design, and wait a second for it to import it. And there it is, and it's in the correct orientation. All the layers are correctly put, and I want to import one sketch per layer, and hit OK. If I expand the inlays, I have all those sketches here that we want to create the designs for. And we can run the plugin that I wrote to do that pretty easily. So let's go ahead, create Inlay VCarve. And it went ahead and flashed because it was going over to the, I'm going to hit cancel. So it went and flashed because it went over to the manufacturer tab to ensure that we had CAM data. And before I do anything, I want to set my tool library to have the tools I want to machine this with. It just makes things a little bit easier, and I've talked about this in another video. So I'm going to go to my tool library, and I'm just going to copy my tools from my cloud location. I'm going to cheat and use my cutting board one that I already set up, and I'm just going to copy all my tools, drag them over to my untitled document. Now my untitled document has everything set up. Okay, I'm going to go back over to design. Let's generate the inlay for the hibiscus portion first. Create VCarve Inlay, and I'm going to name it hibiscus. I do not want a new component. I want to modify the existing body, the existing cutting board body again and again, and not have to create a new body. New bodies are useful for more complex shapes, more complex inlays. The profiles, the hibiscus flowers, target planar face, the top of the cutting board, and let's do a base plug thickness of 1/4 inch, inlay surface gap 0.50, inlay depth, let's do 240 thousandths of an inch, and toolpaths, let's expand this guy a little bit. We're going to use a 15-degree V-bit and then a 1/4 inch, sorry, an 1/8 of an inch spiral down cut for cleaning up everything. And we're going to create a pocket setup and a plug setup. We can always modify these parameters, the inlay depth and the gaps, later. So I'm going to hit OK. Let's go back over and activate the main component, and let's hide the sketches for now. I'm going to hit A for appearance, and let's go to my favorites and let's give it some colors. Let's make the cutting board be walnut, and let's make the hibiscus be cherry. And I dragged over to Hibiscus Inlay. Hit escape to close this guy. Alright, I'm going to go ahead and capture the position of the plug. Now let's take a look at the toolpaths as created, because if you watched my previous videos, it's doing it a little bit different for 2D inlays, and I want to discuss that. So let's go over to manufacture. And let's start by looking at the Hibiscus Inlay pocket. And I'm going to expand it and start looking at these. So the first one is going to be engrave toolpath, and the engrave is going to do a outline of the design, following it like a normal VCarve would, and it's pretty fast to generate. Now let's double click on it and talk about some of the things that are set up on it. So feeds and speeds, those are kind of up to your own machine and what you have to do. On the geometry, the profile selection, the contour selection is set to a sketch, and if I want to see what it is, I can double click on it. It's got a selection here, and then over here on the side it's got a blue underline. We can expand till we find where it is, inlays, and it's not showing it here for some reason. Let's hit cancel, bring it up again. Hibiscus Inlay, sketches, machining boundary. So it's the machining boundary of the inlay. And it's set to start inside, which is important. The plugin just generates all these things correctly. And for a VCarve using the engrave toolpath, the way it works is your top height is your model top, your bottom height is the depth and how deep it wants to go. And these are expressions. So if I click the three dots, edit expression, we can see that there's an expression here which is set to negative inlay depth, and that's how deep it's going to go. So it's pretty simple. Nice thing about VCarve Outline is you could have it do multiple depths. So you could say I want to only carve 100 thousandths of a time or 150, and it would generate 2 passes. Sharp corner angles, usually those, if I reset to user default, is 165. I set it to 180 by the plugin because I think it will make everything sharp, which might be nice. 165 might work for a lot of things. And on the linking, I wouldn't worry about linking, it doesn't matter too much. And if I hit OK, it's going to generate 2 passes for the outline now. Toolpath generation using the engrave toolpath is so much faster than the pencil one. And if I hide the stock and we zoom in, we can see there's 2 blue lines around, one for the first pass and one for the second pass. And then the second thing it's going to do is a clearance. And it's easier to understand the clearance toolpath if we look at the last one. And I'm going to double click on it. This is my 1/8 of an inch downcut bit. And so on the geometry tab, the sketch profiles are set to the same thing as the V bit. And if we go over to the heights, they're also set the same. And the main trick here is on the passes tab, stock to leave is set to this other expression. And if I click edit expression, it's set to a parameter pocket stock to leave. And I'm going to hit cancel, cancel. I talked about this a lot in the first video, but if I go back to design and look at modify, change parameters, if I look at the parameters, there's one that's going to be called pocket stock to leave. And this is set to this special value here, tangent of the inlay bit angle over 2 times the inlay depth. And that just mathematically computes how much it needs to leave so it doesn't actually cut the V-bit portion. Let's go back over to manufacture. All right, so that clearance pass is going to just get as much as it can, but it can't get into the little bits, and so we have a second clearance pass which is set to the V-bit. And so if I double click on that, it's set up the same as the last one. Obviously it's using the V-bit instead of the flat 1/8 of an inch in-mill. But the main difference is on the geometry tab, it has rust machining set. And this is the trick to have it machine all the areas that the larger bit didn't get. And this should be your tool diameter. We used an 1/8 of an inch bit, so it should be 0.125, but it's a little larger. And again, this is an expression. The pocket clearance tool diameter plus 2 times the pocket stock to leave. And I found that that is what's required for it to get everything that the other bit didn't. If you don't do this, it won't work correctly because it won't take in consideration the stock to leave that was left. So that's a basic rundown of the pocket operations that are generated. And the plug's a little bit more complex, as it always is. And I'm going to go ahead and expand this little guy here. So we need the plug to have an extra area where it can carve. If I click on the final toolpath, we can see we have a nice angle up. And that's great for the V-bit. Now the design, if I click away, the top of the design is right here, but it goes deeper because we tell it inside this stock setup that has additional stock. so that lets it go deeper. So if I double click on the Hibiscus plug and I look at the stock is set to the Hibiscus plug stock that was automatically generated. Now let's take a look at the toolpaths that generated. The first one is a roughing VCarve, and the next one's the actual VCarve. This one's set to be optional. That's what that little icon means. You could right click on it and there's a optional option here, and you could delete it or use it. And let's look at this toolpath here first. So we don't want to dive down really deep. We need it to cut the area that's on the stock. And so I just trick it by saying the top height is the stock top and the bottom height is the model top. And that basically does what we need to do. Then the VCarve outline one, this is the one that's actually going to do the design carving. Its top height is model top and its bottom height is model top minus some value. Again, this is an expression, and the expression is minus plug depth. And again, that's just computed. The other interesting things about the plug is the way that's constrained. I now constrain it with 2 sketch profiles. And let's find out what these are. I'm going to double click on the first. It's set to a sketch that starts inside. And it looks like it's highlighting Hibiscus plug here, sketches, machining boundary. So it's going to use the machining boundary, which is just the outline of the whole plug, a basic outline with nothing else. It's going to start inside of it. And then the second one, it's going to start outside, and this is set to the plug design. Should highlight it here, but it's actually the plug design. So that's the main design where it's going to be outside of it. And then it will go and cut inside of it if it needs to, if it alternates the loops. So that's how we limit the machining here. And the engraved toolpath only follows that vector. It doesn't follow any of the 3D shapes that you have in your design. And then, just like the last one, we have a clearance V-bit and a clearance pocket. Now, the interesting thing about these, and this is very different than the original release of the plugin, when you're doing a 2D operation, you can basically reorder these. You could do your clearance bit first and then everything else. And the reason why is because the clearance bit contains this rust machining information inside of here. Actually, this one doesn't have any. And because it contains the rust machining information inside of it, the one that actually does it is this one here, the clearance. Because the rust machining information is contained inside of it, it's not dependent on the order like a 3D toolpath would be. So we could do the clearance first here, which would remove most of the stock. Then the roughing really would do hardly anything in this case. If we did clearance first, we could probably delete the roughing and then just go straight to the VCarve outline. Again, if you want to limit the depths, double click on it, go over to multiple depths. You could limit it to, say, 150 thou or something. And this isn't a very deep carve, so it would only do 1. And then the clearance V-bit. Now the clearance is just a pocket operation, and you might want to do multiple depths with the pocket. So we can double click on that and go over to the passes, check multiple depths, and let's say we want to do 1/8 of an inch max step down. And then you can go ahead and close it. And that will step it down a little bit easier for some machines. Now the clearance with a V-bit doesn't have that option, but that shouldn't be an issue because it shouldn't be cutting a lot. If it is, you have to duplicate it and do the roughing operation type of hack that I talked about at the start. Let's go back over to the design workspace and let's do some customization on this, because a lot of times you're going to be gluing up ingrain and you're going to have a particular stock size and you want to customize it. So let's do that. We can customize the plug a bit, and the Hibiscus plug is here. Activate it, and let's right click on it, isolate it, just get rid of everything else, and we can expand the items down here if we wanted to see the timeline. Expand it here in the side. I'm going to collapse some things to make it a little simpler. And we can expand the sketches, and let's take a look at the sketches that are automatically created. So plug design, and that's the limiting area of the design, just the design. If I hide the bodies, you can see it's just the design. It looks a little funky, and that looks a little funky because it has construction profiles shown. Now the plug profile, if I show the plug profile, that's just the outline of the whole plug. So if we wanted to say have a specific size for the plug, we would edit this. And so let's go ahead and do that. I'm going to double click on the plug profile. And things moved because the plug was created at that point in the timeline right above the cutting board. I'm going to look at it from the top, and let's show the plug design. Make sure that we can always get around the plug design. The plug design looks really busy. Let's hit Finish Sketch here. Let's go to plug design, double click on it, and I don't want it to show points, and I don't want to show construction geometries. And I'm going to hit Finish Sketch. And that gives me something that's a lot cleaner to look at. Back to double clicking on the plug profile. And here is where you would set the plug profile to the actual dimensions of what you're creating. So I'm going to go ahead and create some constraints. Let's create a perpendicular constraint between some of these edges. I just click perpendicular constraint and then click the two ones. And now I have a constrained rectangle. Hit escape. And let's hit this edge, hit D. And let's say we start with a stock that's 6 inches. And let's see how long the bottom was. The bottom needs at least 16 and about 1/8. Let's go ahead and let's just make it 18 for kicks. And hit escape to go out of the dimension mode. And then let's just drag this around things a little bit better. So that gives me a larger specific size of the plug stock I would need to make, an 18 by 6 inch piece of plug stock. So I can hit Finish Sketch. Now let's take a look at some of the other sketches that are created here. The machining boundary. So I'm going to show that, hide the plug profile and plug design, and it's a projected area of the plug profile. And this is going to be the area that the plug's machined, which we might want to customize. And let's do that. I'm going to double click on the machining boundary, and I'm going to go ahead and show the plug design. And let's go ahead and select everything, hit delete, and create our own machining boundary. And it only deleted the things in this sketch, the plug design one. It's just showing, it's not something that's projected here. And let's show the plug profile so we have a boundary that we don't want to go outside of. And let's create a fit point spline, and let's just make a little bit tighter of a profile around this plug. Just going to quickly do this. You could spend a lot more time creating nice profiles. Hit escape. And the things that you're looking for is you want to be inside. You don't want to overlap your plug because, well, I don't know what would really happen. All right. Now I can hit Finish Sketch. And let's go look at the clearance machining boundary too. Double click on that one. And that's just a machining boundary that's slightly outset from the interior one. And that was just so we could machine everything. And really, we go ahead and select it and delete everything in the clearance one. And I want to make it identical to the machining boundary because I have a custom machining boundary. Hit P for project, go to specified entities, and I'm going to select the line from the machining boundary, okay, and hit Finish Sketch. And now if I go over to manufacture, we can see what's going to be different about the plug. Click on the plug here, and I'm going to expand the plug in the side, and let's hide those sketches. Go over to clearance, and let's just regenerate all these toolpaths, Command G, and see what happens. So the clearance toolpath now is clearly limited to that area, which is pretty cool. We don't have to cut a lot of other stuff. We could actually have hold downs that hold it down and not have to machine the entire top. And while we're speaking about that, we probably do want to do a pocket operation on the top to get it to be really clean. And that's something that I do for my plugs. So let's go ahead and do that now. Let's add a 2D pocket. And let's use a 3/8 inch spiral upcut. And Let's go ahead and set a pocket selection of that machining boundary, that same machining boundary. And when I clicked on it, notice that the darker blue area is on the outside. We want to be on the inside, so you can click the red arrow and it will go to the inside. Hit OK. We want to do this first, so I'm going to drag it up here. And let me double click on it and add some other modifications. So heights are important. We want to feed from above the stock top, maybe 0.2 inches. The rechecked height's now got an error. Let's go higher on that. The bottom height, we want to machine to the stock top on the plug because that's very special stock that we created. Our actual stock might be a little bit bigger. Hit OK. And so if it's going to generate a toolpath, then that's just going to machine the top nice and perfectly flat, assuming we're going to start with a plug that's a little bit thicker and a little bit rough. Then it's going to go ahead and do the clearance of the middle area. Then it's going to do the VCarve outline. And this emphasizes something about the VCarve bits, the engraved toolpath. It is going to do a pass all along the profile edge. And the pencil operation for 3D ones doesn't do that because it follows the model. This one's just following the inside profiles, and there's no way I've figured out to get rid of that. And then the last one's the clearance, where it cuts out and does the clearance. So this would be a great way to cut the plug. We do a pocket to the top, clearance, outline, V-bit. Pretty simple. Okay, let's go ahead and create some more plugs and inlays and customize them even further and in a more advanced way. Let's go back over to design. And let's hide the plug that we're working on. Let's show the board. And let's hit the home button. Let's activate the inlays, collapse a few things, expand the sketches. Let's create an inlay for the leaves. So create VCarve Inlay. And we're going to call it leaves. I'm going to target the existing board, uncheck new component. Profiles are the leaves. Target is the existing board, the top of it, and everything else is the same. I'm going to hit OK, and it's going to generate the inlay for the leaves. So what we see in the plug is something that we're going to deal with, which is a very sparse layout. First, let's go ahead and activate the main component, capture our positions, hit A for appearance, and let's drag the maple to the leaves inlay, and for kicks, let's show the hibiscus inlay. Escape. Hibiscus inlay. Cool. And yeah, we have a very sparse layout in the plug here, and let's make it a lot more dense. So we want to work on the leaves plug, activate that, right click on it, and let's isolate just to focus on it, and let's expand it a little bit, hide some sketches, expand its sketches, and like before we have the plug design, plug profile, machining boundary, clearance machining boundary. Let's double click on the plug design. Again, things move because it was actually created over where the board was. So I'm going to look out from the top, and let's turn off construction geometries, and let's turn off points to make it cleaner. So one of the new things I did is to not link all these to the original inlay. And that allows you to move them around, and we're going to do exactly that. So I'm going to select this guy, hit M for move, and we can just start dragging them to a tighter location. So I'm going to select them, in for move, drag them over a little tighter, enter to accept, select, in for move, drag them over. Let's make a tighter location. Let's make some really small plugs. In for move, in for move. Now, once you start doing this, you're going to have some way of knowing where they were and where they go back to if the shapes are pretty similar. Some of these are pretty similar, and it might get confusing. All right, that's a much more dense layout. If I hit Finish Design and I look over at our plug, it's way denser, but we have that huge stock piece. So let's modify the plug profile by double clicking on it. We'll look at it, scroll to it, and we want to see the design. I'm going to show the plug design, and we could just make the plug profile smaller like before. And I'm not going to do too much to it this time. Hit finish, and we'll have a smaller plug profile. And there it is. But let's go a step further this time, and let's customize the machining boundary a whole lot. So I'm going to go ahead and we want to modify this shape and create another sketch to modify it. So I'm expand the timeline here, and I want to go before the machining boundaries. So I'm going to drag the timeline to before those were created. And there's a lot of ways to do this. You don't have to do it this way. It's just one way of doing it. And they disappeared because this guy's over at the origin. And let's go ahead and create a sketch on the top here and then look at it. Alright, this sketch is going to be the custom plugs. Let's start by hiding the plug body. Let's project all the leaves from the plug design. So I'm going to double click on them. And projecting, you have to double click on each design that you want to project to select the whole thing. Double click, double click, double click. I wish there was an easier way to do this, and if you guys know a better way to project sketch elements like this, let me know. This is something that a plugin could generate and be nice to have. Alright, hit OK, and I'm going to hide the plug design. Let's hide points, and let's hide, yeah, alright, there we go. Things look cleaner. Let's hide the plug profile. Actually, let's project, no, let's not project it. Alright, let's select all these guys, and let's make them construction points by hitting that button. They became dashed lines. Let's hide the plug profile. So we want to create outlines around each of these guys to cut them out, and just something that would be nice to do. So let's select this guy, hit O for offset, and create an offset around it. And I just start dragging it till it creates an offset, about 1/4 inch, doesn't matter. Hit enter. And these guys are close together. Let's do them later. O for offset. And so I'm just creating offsets around all the leaves. If they don't go the right way one time, I go the other way. O for offset. O for offset. And let's zoom in here and select all these guys at once and hit O, and let's create an offset around them. And okay, it acts a little weird, and let's try it like that. Hit enter. And it gave some errors and warnings, and all our profiles, the blue areas, disappeared, so that caused a lot of trouble doing that. We might be able to trim it and fix it up. So if I just delete some of these bits in here, it just fixes how Fusion determines what's an inside and outside profile. And we get warnings, but that's okay. We're kind of going with this. And we could do the same thing for here. O for offset, O for offset. Pick whichever way starts going outside of it. Hit enter. And these ones didn't do that weirdness, but we can trim them anyways, and it deletes the constraints. And now finally, let's show the plug profile. It looks like we went outside the plug profile a little bit, so let's move the plug profile up a little bit. I'm gonna hit finish sketch, double click on plug profile, and just inch it up a little bit. Finish sketch, back to custom plugs. And now if I hit P for project, I want to project the plug profile into this sketch, double click on it. Okay. And once I did that, this whole area turned blue, which is awesome. We can hide the plug profile. And we can show the plug body. So now what we can do is we can hit E for extrude, and we can extrude down, and making sure we're just cutting only our plug body. Hit OK. And now if I flip around, we have a bunch of individual little plugs, which is pretty awesome. Now let's go next forward in the timeline, and the machining boundary is going to be it's not going to be changed yet. So if I double click on it, and we could do a customization of the machining boundary, and there's other ways to do this I'm going to talk about in a second. But I'm going to hit P for project, and we're just going to project all the bodies into the machining boundary. And the only reason I'm doing this is because they are linked to the toolpaths, and you don't have to do it. So I'm going to click the clearance machining boundary and do the same thing, P for project. You could go change these inside of the toolpaths, and I'm going to show how to do that in a second. Now let's go over to manufacture. Actually, before manufacture, let's make sure up at the top we are at the end of the timeline, because we actually weren't. And if I hit home after it regenerates stuff, see where we are. There's all the plugs facing up. Go back over to manufacture. And now we can look at leaves plug, and I'm hit Command G to regenerate all the toolpaths based on all the changes we made. And it's going to do a roughing VCarve outline like before, the actual VCarve outline. And then it's going to do the clearance one with the V, and then the clearance with the 2D pocket. And if you look at this 2D pocket clearance, it's really tight. It's not doing anything excessive, just right around those guys. And the V-bit's still calculating. Now, like we did with Hibiscus plug, we probably want to do a pocket on the top. And so let's select the clearance from the plug, hit Command C to copy, go to our leaves plug, Command V to paste, goes to the end, click on it once, drag it to the top, and double click on it to customize it. And let's go to the geometry tab, delete the closed chain that was going to cut, and let's just go and do a silhouette. We want to start inside the silhouette, so we're cutting inside. Hit OK, and make sure our depth's right, top height, stock top, plus a little bit, bottom height, stock top. Cool. So this is going to generate a cleanup of the top of the plug, which is going to be the part you can actually insert into your inlay, and it's going to be nice and flat. Then it's going to go ahead and do the V-bit, and then the deeper, proper V-bit. Clearance is still computing, and then the other clearance here. So that finished computing. So this is how we could generate some toolpaths for a plug that don't run very long. I mean, we're looking at, like, based on the simulation, maybe 15 minutes to cut all these out. And speaking of cutting these out, let's go ahead and cut them out. So let's do a 2D contour. And let's select, I'm just going to use the 1/8 of an inch bit. I wouldn't ever use an 1/8 of an inch bit to probably cut out something like this. Geometry, we want to cut out a silhouette of these guys. And we want to start outside for cutting it. Let's add some tabs, and I always like triangular, and yeah, let's just go with the defaults. And top height, stock top, bottom height, let's go to the stock bottom. And you would probably tweak a lot of other things, but we're not going to do that. Just hit OK. And let's wait a second for it to pop in the preview, and that's awesome. It's going to go ahead and cut out each individual plug so it can easily glue it in. And of course you could tighten things up a lot, and this is just an example. And let's do another example of, let's say you want to just cut this single plug here because it was messed up, or you just want to do one at a time. I don't know. It might be easiest to start with a new setup. So let's do a new setup from scratch and show how to do it. And let's first, by selecting that model, let's find it over here. Expand the plug, and let's see, I can just click on it. There we go. Stock. I'm going to go to relative size box, add stock to all sides, and here's where we can do a trick. Normally we would select the stock that was created by the plugin, but instead we could just do the correct calculations here. And what we have is plug additional stock parameter, and if you just type additional, you can see it here, and that's going to create on the top the Z plus, the additional stock that we need for the plug, just like it would do for the other stock, the model that was created. And so that's pretty cool. We'd probably set the origin, because I like the origin to be here. I'd probably flip some things, but we're just doing an example. And now under the 2D toolpath, there is a VCarve Inlay pocket option, which will generate toolpaths. And so it wants you to select the design sketch, and we're just going to go ahead and select the plug design. And we're just going to use this as a basis for creating some toolpaths. We could copy and paste them from before, but I'm not going to do that right now. So it's going to go ahead and, oh wait, I select the pocket. That was wrong. I wanted the plug. Undo. 2D inlay plug. And we could select the plug design and a machining boundary. It doesn't really matter. We're gonna change those in a second. And expand it. So now it's creating toolpaths for all of them, because the default selection was that over here, the sketch profiles. I'm gonna delete these guys. And let's just have it rough out this area of the pocket. That's the contour we want. And you could go ahead and do a pocket selection. You could select this pocket. You could select all of them that are the same in case you have multiple pockets that aren't connected. This one does have them connected. And then hit OK. And if we wait a second, that should generate the VCarve. Well, it generated on the inside, which isn't what we want. Okay, it went ahead and did it on the inside, which is wrong, so pocket selection won't work for the VCarve one. And so let's delete that. And let's just go ahead and select the actual contours. So a closed chain of where we want the limits to be, 2 closed chains. So we can have it be either inside or outside. This one needs to be inside. Not sure which is which because it's really hard to tell with that arrow. So we'll just see if it generates stuff right. Hit OK. And wait for it to generate. And it looks like I got correct. That kind of looks like the plug of what we would want. If you didn't, you'd have to flip the arrows on one of them until it looks correct. And we don't want to do the same thing for the next ones. So the actual outline one here, let's go over to the geometry and let's chain it like before, selecting the previous. Hit OK. And while that's generating, let's do the same thing for the V-bit clearance. Double click, go over here, delete what it has, and expand the first one, select its contour selection, OK. And the same thing for the clearance. And here, delete, delete, and select the first one's contour selection. Hit OK. And let's see what it's doing. So it's V-carving a rough pass first, the deep proper height of the plug, a clearance pass of the bit to remove all the extra stuff. And that one looks like it's actually doing the wrong thing. So that one we're going to have to fix. And then a clearance pass, again, it looks like it's doing the wrong thing. It went on the outside. So let's fix these guys up. Double click on them. Pocket operations, you can just select the pocket that you want to cut. And so let's do that for the pocket operation. And my point here is kind of just showing how I figured things out. I look at what it's doing and figure out what I need to select until it looks correct. So that's correct. It's generating the clearance outside, and then the V-bit clearance is going to be outside too because it's the same thing. And so that looks correct. So this would be a complete fresh setup generated from scratch to make just a single plug. And that's pretty cool. Now, other things you could do is you could actually line up all these plugs and cut them out of strips of wood. There's just so many possibilities that you can do once you kind of start playing with this idea. There we go. All right, now let's go back to design. So those are a few ways you can customize the plug layout. I'm going to hide the leaves plug. Let's go and activate the main stuff again. Show the inlays. And we could go ahead and create the other ones too. Create VCarve Inlay. All right, so that was a ton of information, and I didn't even talk about some of the details specific to the cutting board, like surfacing the top, maybe leaving a little bit extra for you to have for sanding off later or machining off, and maybe I can discuss that in the next video. But if you do want to see all the exact toolpaths, the CAD and CAM that I created for making this exact cutting board, I'll have a link for it down in the description. So thanks everyone. Post your comments below and your questions. I love hearing from people. If you make something cool with the plugin, send me a picture. I love seeing what people make with it. And as usual, thanks everyone.